Welcome back. In this video, we will continue our work on the backend. And as you might have recalled yesterday, we did the basic by setting up, or what we did in the previous, the basic backend, getting a response from the HTTP server, setting up a health checker, getting the database integrated, and creating a basic user table. And so today we're going to continue working on this. We will move to building out the various components we need to manage the user sessions and manage the users themselves. So we will not implement login functionality, but we will implement the user session store we will need in order to check whether a user is authenticated or not. So the first thing we want to do is go to our Auth app library. This is right now just a standard library with nothing in it. We create a new file here, which we call user session.rs. And so inside of this module, we'll import the user object. We'll import the date and the time, UTC, and the ability to serialize and deserialize. Then we're going to create a struct for the actual user session. So this is the thing that we'll be keeping in the database to make sure that whenever we get a new request, that we can figure out what user made that request if they're logged in. If they're not logged in, it should of course be an anonymous user, which means that we need to have the possibility that the user object might be none, right? And so we're going to just do user option user here, and the login time, which is going to be date time, UTC. Okay, this is our very simple user session, right? And it's serializable, deserializable, so we can store it in the database. Or for that matter, in a memory store, if that's the thing we want to do. The first time I implemented this, I actually did it just in a memory store, and you can do that as well, but that does not scale across multiple instances, so this is why we would want to do this in a database. Next, we implement the user session. So we need a function for creating a new session, and the new session may or may not have a user. It returns self, and that's with the user, and then the login time, which is just UTC now. And that's pretty much it for our user session object. Alrighty, let's see. Next thing, we need to be able to store this user object. In order to do this, we're going to make a Postgres store. And so the Postgres store is simply just going to have a schema. Okay, so wait, let's step back. We're going to derive clone and debug for this thing. And this Postgres store itself is just going to have a database connection or database pool connection, schema, a name for the schema that we're using, and a table name. And actually, we need to import a few different things in order for this. So we'll be using Tower session storage for it. And so we are importing some basic stuff here. We're importing the PD connection, the PD pool, some time stuff. So this is a modified version of the one we have in Tower Sessions. The reason why we did I did a modified version of it is because I want to be able to cross-compile it from ARM to x86. If you don't need that, you can go to this address and just use the original SQLX Postgres store. Okay. Next, we want to derive some errors. So we're going to make an enum for the different kind of errors that could happen. And we're using this error for that, just to make sure that we get nice formatting without any problems, as well as the ability to inherit from other errors, which makes conversion super nice and easy. So we're going to use this from, which allows us to convert a SQLX error into our own enum. We need to have a square bracket here. And finally, we need to have a, oh, there's something wrong with the indentation here. We don't need that one. There still seems to be an issue. What would that be? Error, is that from the previous one? Ah, right, we're just missing the next thing here. Okay, so let's just walk through what this means. Decode. Okay. So transparent means that when we are converting this into an error message, we will just use the inner class here for actually doing the conversion. So that one has already a conversion defined for it. The from macro makes sure that we can easily use into, which means that we can cast the inner error into our enum. This is super helpful for just making it very, very nice and easy to work with. Right. And then the next thing we want to do is make it such that we can convert this SQLX error into a session store error. And so what we do is we simply just make it such that we convert the inner error into a text. So the SQLX error, whenever we get that one, we get the inner one and we just convert it into a string and then add that to our session store error. So this is a very simple mapping we're doing. Okay, Finally, we need to implement the session store itself. So this one will have a new function so we can construct it. New function takes a PG pool and returns self. It feels like we are missing something here. Self, yeah, there's definitely a syntax error in the previous part of the code here because the thing does not indent correctly. Let's see. That one matches, that one matches. It should be okay now. So why does this happen? Let's just try to compile it and see what the issue might be. Oh wait, we don't have that one in the tree yet, so let's add them here. Right, so one issue is we have an S too many here. And we have a couple of other issues, so we missed the commas here. And then, of course, we haven't actually added any dependencies just yet. So let's just do that. And for that, we're just going to add a bunch of different dependencies here. So base 64 chrono futures. We actually don't need Redis, but we could use Redis for storing the user sessions as well. In our case, we're going to do it in Postgres. We will be using SQLX, we'll be using the Auth API, we'll be using all of these things. Okay, so that should be fine. Once this is being turned into a course, you'll get all the snippets alongside with the videos, so you can copy paste some of it as well, just to make your life easier, because just writing out these dependencies is going to be relatively boring. Yeah. Once the video is done and made as a course, look in the text accompanying the video and you'll find the necessary code bits that you need to make things work. This does not exist for now though, so for now you'll have to copy it off the screen. But it will eventually. Okay, let's see, did this fix our indentation issue? No, this still does some stuff here. Let's see if we can figure out what else is the problem. Async trait is not there yet, but we will definitely need async trait eventually. So let's just add that one to our dependencies. Base 64. Right, that one we are actually using in the front end. I thought, oh no, we're not. We're using it in the wallet, aren't we? Wallet app. so let's take these ones. We're just going to move them all to the top level here and update this such that we use the workspace version of it. Then, right, we are sure that in that way we're sure that we're using the same version everywhere. And oh, what did we do wrong here? Okay, cool. So that should be fixed now. We have made sure we share the things chrono, workspace, duplicate entry in table. Right, so we already had chrono and now we copied it back in. Axum seems to be duplicated as well. Oh no, Axum is not duplicated. It's actually not there. So that one comes from the backend. I'm kind of surprised. That one ought to be there. It's right there. So why is it complaining? Right, we have cert being this duplicated as well, don't we? Yeah, that one is up here. But we want to have the version that supports derive, so we're just going to update that. Failed to find Auth app. All right, okay, so the issue here is that it fails to load that one because the Auth app is having a inheriting futures, but I did not see that one. Oh, that's because we looked the wrong place. Right, that one is right there, so we'll need to find that one as well. Let's add that into our manifest. This error our cookies. feels like we have quite a few things we need to add. I don't think we have any tower stuff in here. Oh yeah, we have tower HTTP, but we have no tower sessions. We have no, so that we probably want to have session core. We want to have SQLX store. Is there other things we need? I think not. Let's see. Wait, I thought I just. Right. Tower sessions. Wait, why is it complain? Oh, we need to close that one. Validator. Let's just see, why do we keep on getting this thing? Failed to load manifest backend caused by, right. So I wonder what tool chain, so this one is using a different tool chain from what we are using. That's something to look into, how to update that. Because that is slightly annoying to get that error message every time. Right, and so here we have the problem that it will not serialize and deserialize our time. So for that, we need to find our dependency cert. And this is because we have, so the serialization, deserialization framework has different features we need to enable. And in this case, we need to enable the Chrono support, which will make sure that if we are using Chrono, that it'll be able to serialize and deserialize the content of a time object. What happens if we just do this? Will it go away? It will not. Let's just check the documentation and see if I actually recall correctly. Oh, wait. It's the other way around. It's not cert that needs Chrono, it's Chrono that needs cert. Right. Okay, and then we are missing a keyword and a few other things, and this is the reason why we started investigating all of this and just getting everything up to scratch. Inside here, there was something that didn't quite work out as we wanted to, and that's because we forgot the keyword fn in front of here. Okay, and then while we're at fixing stuff, let's just try to jump right here. See if this fixes the issue. Try to jump back here. Okay, now it stopped being annoying. So this is great. We can now continue the work. Right, so here we're returning self with pool. And together with the pool, we're going to add a schema name and a session name. And so we're just going to call the table name for session and the schema for tower sessions. Then and basically we're going to this address up here, and we're just copying the remaining functions. And this should get us going with where we want to be. And then we can get on with actually implementing the user sessions. So we're implementing the functions, and we also implement the async trait for deleting and maintaining the store. Okay. Then with that, let's get on to the next bit, which is implementing our services. So the structure we are using for the backend is very similar to what you probably have experienced in other places. We first define a repository, then the repository is used by the service to provide services, and the service is used by the controller, and the controller is used by the handler. We're going to make a slightly simpler version here where we're just where we're merging the repository and services into a single unit, but in a more advanced version you would divide these two. And so the first service that we will be defining is the Auth service. And this will be a public struct that we call Auth service. And it will only have a pool. So in a more advanced version of this, we would probably have a atomic reference counted pointer to the repository, and then the repository would be implemented with a trait. But for the sake of keeping this short enough that it's digestible, we're going to skip that here and just do it all in a single thing. Then, as usual, we will need a new function, a static function that allows us to create a new Auth service. And then we want to have a few different functions. We want to have an authenticate function. We want to have a login function. And we want to have a logout function. And so the login and logout are taking session objects so we can populate the session with the necessary data or remove it from the session. And finally, we want to have a get users function. We also want to have a get users function by username. We want to have a we want to have a similar one, get or create user, and a plain create user, and a delete user. And last operation we want is a update user. Actually, that was not the last one. We also want to be able to verify the username. So the majority of these we're not going to implement in this video. We will stick with the very basic ones here and just implement the authenticate and log in and log out. And so the authenticate is going to be quite simple. We will get the user from SQLX, and we'll do this as query as. And you'll notice here that I don't use the macros in SQLX. If you want to use the macros, you can do that. It will make your life a whole lot simpler. The reason why I don't use it is because I like to cross-compile things. It makes things a little bit more verbose in how it's written out. But overall, it's not too bad. That being said, like, the macros are awesome. So if you're just working on a single system and never having to worry about cross compilation, use the macros because they will make your life so much simpler. Right. And so one important thing here is this bind operation. This is a thing that's super important to do to avoid injection attacks. So SQLX has this thing where you write out your query and then you have $1, $2, and so on and so forth. And when you use the bind parameter, it will automatically sanitize that and make sure that you are not subject to injection attacks. So you should definitely do that whenever you can, and avoid using format. That's just bad practice. Okay, if there is an error happening, we want to know about it. And we want to return an internal error. We probably also want to do log error failed to. Actually, in this case, do we? Yeah, we do want to do this, and we want it to be an internal. Failed to get user from database. Cool. Then if we do get a user, it will be an option. And so that option we are going to unpack. If it's a user, we just return, okay, it was a user. If in any other case, we're going to return a bad request, or we could return not found. That's probably more appropriate for this case. But in any case, this is something you can play around with yourself. Then this allows us to just get a user by user ID and basically authenticate whether this user exists or not. But then the login is going to do a slightly more complex process where it will first authenticate and then it will set the session afterwards. So we start out by authenticating the user, and then we are returning an error immediately if that happens. Next, we are going to create the user session. So remember, this was the object we created a little time ago, and this would be user session new some user.clone. And then in the session itself, we're going to insert this as the user session, and then user session. we will await this. And again, we will map the error if an error happens. There shouldn't happen an error, but who knows, it can happen. And if we're successful, we will return the user. So this was authentication. Let's go to logout. So logout is basically just a process of deleting the user object from the session, and this is quite easily done by using remove. What we're removing is a user session and user session. And we'll await this. And again, we'll map the error similar to what we did up here, such that if something fails, we will know that things went wrong. And we'll get logs that will tell us that we need to fix some stuff. And this is about as far as we'll go for the services for this version. Let's see where we are in terms of compiling things, whether they compile now or whether there are more things we still need to fix. Right, we still have a few different things we need to fix here. All right, that's misspelled. We need a G in there. So let's just see. All right, things are compiling. So we're one step closer to getting things working. We still need to define the services module here. And we see now that we have forgotten to import some stuff. In fact, we haven't imported anything at all. So that arguably could be a bit of a problem. So let's just import what we are missing, and that should get us in the game. Oh, right. That's a very good point. When you leave implementations empty like this, and you want to save them for later, you can add to do. So right now we're getting a ton of compile errors because we're not returning the return type that Rust expects. And so it'd be like, hey, you're doing something wrong here. You should be returning a result that either have a user or an error. And we're doing neither of that. We're just having a comment in here. But if you add to do, it will add a panic, and then it will add a unreachable instruction, which is great because that makes that our code can compile without that we actually have to do the full implementation. And should we ever accidentally invoke any of these functions, we'll know that we invoked them by it panicking. And it will have a very specific line number, and we'll know exactly where it is we need to make the implementation. So this is another cool thing, like compare this to JavaScript. There you can have an empty implementation, forget about that you implemented, but there is no way of knowing. Whereas here, if you forget to implement it, it will complain for sure. Right. Logout. Seems we have an error there. We need to return a unit result for this function to be correct. Okay, everything's compiling. We have the services. That basically makes so we are getting to the exciting bit, the handlers, which is what we need for getting your user. Yeah, getting the user and locking out. So these are the only handlers we will be implementing, and we'll do this by just creating a function app, and inside app we will have /myuser. This should be a get request to the myuser handler, and then a logout. So login we're going to do in one of the next videos where we'll implement password login. But for now we just need the ability to log out and to get the user. And for this to work out, we as usual have some things we need to import. Particularly we need some extensions. We need to be able to get the extension, the service extension for our authentication framework. We need to be able to get the session and a few other things. And then with that, we will define the my handler, which as the first thing will take an extension of service. So what this does is it tells Axum, I have an extension defined at the server level, and this extension I would like to load in this particular view, right? And so the extension should be of type arc of service. Right. And what we will return is a result, which will either be a user or it will be a error response. And inside here we'll just get the user of service authenticate. And the other thing we will need is something we actually haven't defined yet, which is the user authentication guard. And so what service.authenticate does is it takes a user and makes sure that that user still exists, right? And then if it exists, we're just going to return that user. If it doesn't exist, this authenticate will produce an error, and the question mark will make sure that we go down the error result road. Okay, but this one we actually need to implement. We will do that by creating a new file which we call userguard.rs. And like the previous, we will have some imports we need to do. And then the user guard itself is going to be a struct that will be serializable, deserializable, and all the usual things that we like to have, debuggable and clonable. User authentication guard. And then we are going to implement a async trait, which is using the from part in Axum. And what we will basically do is we will create this or implement this trait from parts that needs to implement a async function that looks like this. That's called from parts. And this allows us to work like this, that whenever we put the user authentication guard inside a function argument of a handler, this particular piece of code will be executed in an attempt to try to extract a user authentication guard from the request itself. So we have the parts, and we now need to get the different the user session. So we have the parts, and we now need to get the user session from these parts. And so the way we do this is we're using session, and we're going to do session from request parts. So this one is already implemented for session, since you can also ask the session to be part of a function argument, right? And so we're just invoking this to get the session itself. And then we are going to await, and we're going to map the error if such a thing happens. And if that happens, we will return an internal error. Okay. And then from the user session, we're going to extract our actual user session, or from the session, we're going to extract our actual user session. So remember, we stored that under the variable user session. So we're just going to get that one, await, and then map the error in case we don't have this object, or in case we can't get the object. So that it should give an option back, which is either none or some. But in case we encounter an error, such as a database connection, we are going to just return an internal error. Cool. Then from the user session itself, we are going to match user session. And we might have some user session, or we might have none, in which case we are going to return that this was an unauthorized call. Right? The same inside the user session, we are going to match the user, which again might be none or might be some. And if it's some, we're going to return OK, user authentication guard user, and none, we are just going to return the error again. We could probably make this slightly more or we could probably make this better looking by simply just doing an early return here instead of, oh wait, there's something wrong here. This one needs to look like this. And then this is, okay. This should be right. By making it the default that we return this, actually let's just refactor this on the fly and say the default is that we return none, and then we just do a none here, which this looks slightly nicer if we do it this way, not as, and then we just do a return here. See, and we need some commas for this to work out. So this basically just means that we're exhausting all the paths for the user session. We need the user session to exist, and then we need the user inside the user session to exist. And if that's the case, we're going to return a successful user guard. Okay, let's see. We need to add this to the library, pub/mod user guard. Let's check that things are still compiling, or if we did some random mistake. We did some random mistakes. But this is in the handlers, so that's that's where we left off. And actually, I think this is a very logical thing. We don't have the, we do have the my user handler, but we're missing a comma here, right? And then we wanted to have another function as well, which is the logout function. And so the logout function is that simple. We're just going to do auth service. That logout. And for that we need the session. And we are waiting. Unsatisfied, right, so from request parts, from request, I wonder, is this because we forgot to import some stuff? Let's see. So first of all, this one. In the handler itself, we need to import the user service. We're not actually doing that. But obviously we need to do that. We also need to import the user guard itself, right? The authentication guard. Otherwise that's not going to work. Okay. Right, we need to do, no, we have done that. So why is it complaining about that it can't find that one? Did we not call it user authentication guard? Maybe we did a spelling mistake. Yeah, we did. Authenticated guard. Right, and authenticated guard. Okay, let's try this. Error response. I would have thought we imported that one. That one is right there. So what's the issue here? Really? I do not get this at all. What the? Like, it's right there. We are definitely importing it. Are we misspelling it? Error response. I'm sorry, I don't. Oh, we have interchanged P and S. Holy crap. I would never have figured that out if the Rust compiler weren't so good at telling me what I'm doing wrong. Like, I would have looked for on those two words forever. Right. User session, that one is easy though. That's misspelled. Should be user session. And then this one. Why does it do that? Get request from parts. Authentication guard. This is definitely wrong, right? We have just established that this should be authenticated guard. Okay, let's just try to change the version of Axum, because it might be that they've changed the interface since I wrote the first version of this. And so we're just going to downgrade to one version earlier to check if that would be the issue. All right, let's go. We have everything compiling now. So the issue was that they've changed the interface slightly. So in order to upgrade this, we would need to do a slightly different implementation. This is not so relevant to the course itself, but I would encourage you to always keep your libraries up to date. I think that's good practice to do that. And with that said, let's get on with the next thing. So we basically have defined our handlers now. We've defined an application that we can easily add into our backend. And so you see, we have this isolated module Auth. And now all we have to do is import app and import the service, attach that to our server, and then we're done. But then when we do the next project, we can just copy this whole code base over into that project and then attach the things again. In that way, we've built things up in a way that it's super modular, super easy to reuse, and this will just make our life so much easier in the future. And let's see. I think where we want to go next is the main. So where as the last thing, we want to update the main function. And inside of here, we have the database connection. And then right after the database connection, we want to create a, well, actually after the migrations, we want to implement a Auth or create the Auth service. We also want to set up the session store. It's just taking our Postgres session store and creating a new one with the database, then performing the migration if we need to. And then we're going to create a deletion task that's running in the background, just deleting all the expired tasks continuously. Cool. Then setting up the session layer. This is where, if you recall in the beginning, in our .env, we created the server secret. And we're going to reuse that one here. Or not reuse, we're going to use that one here and just do server secret equal std env, and then we're getting our server secret that unwrap. Actually, let's just do an expect. We will assume that the server secret is encoded in base 64, so we're going to just decode it. We're using the same engine as we used before, where we are using the base 64 engine we used in the front end to just use the standard algorithm to decrypt the secret. If we can't do that, then we have a problem. And then we will load the key from the decoded secret. So the key itself, oh, wait a second. The key itself we will get from the tower sessions, and so it has this cookie key which we will inject and make sure that we have in the requests for continuously managing the authentication. We will also need to import our we also need to import our Auth or our app as Auth app and the Auth service, authentication service. And the Postgres store. Having imported that, we're moving down below the domain. So we defined this domain group that we'll be using. And so the point of the domain group is that we'll be using this for storing the key in the cookie that will be managing our session. And the whole setup here is made so that we can do this across subdomains, which is why we have this relatively complicated way of defining what domain we are working on. And with that, we are going to just take this standard snippet that you find in the session documentation, where we're taking a session manager. We're creating a new session from the session store that we have just created up here. Or did we create that one? Maybe yeah, we did. We did create it here, right? So we created a Postgres store up here. And we are just adding that in here, saying we want this to be secure. We want to use the domain. We want same site to be none. And here's the expiration for the cookie itself and the key that we are signing with. And let's just take the auth service and move it down here. I don't think, did we use it? No, we did not. Good. So we're moving the auth service down here. And our final step will be to attach these things to our system. So the first thing we're going to do is we're going to nest /API come here, Auth app. And so what this will do, if we go back to our Auth app and look at the handlers, is it will nest these ones under the subdomain /API. Next thing we want to do is we want to add our session layer, and then we want to add our authentication service as an extension, and that should be it. We should be done here. Okay, we have not imported same site. So that one should be imported here. We also did not import arc, so this is the reference, atomically reference count smart pointer. Base 64, we haven't added that to the cargo file. Tower sessions, same story. No app in the root, so we forgot to export we need to re-export app in the thing, and that should tower sessions. Right. This is because this needs to be a dash, not an underscore. Import the engine. And what else is it complaining about? Yeah, it's base 64. Auth service, we have neither exported that, we have neither exported the pub use services, pub use Postgres store, and we want to all right, there we go. We have now gotten to the point where we have a system up running, and we have the logout function, we have session management, we have a way of keeping the user object inside of the session. We have a basic user service where we can check the user. We have the user table. We are ready to move on and now create the password and the password authentication as the next step, and then move on to the front end and start integrating all of these things. So I'm super excited about this. It feels like we've made a lot of progress. In the next video, we will dive into building up the password and how this will tie into our user service and our auth module. I hope you enjoyed the video.